So I'm Yaron. I'm a founder and CTO of Iguazio. Iguazio basically is named after Iguazu Falls, which is, from our perspective, a good illustration of volume, velocity, and variety, just with I/O. And we're still in stealth mode, so I won't tell you exactly what our product, but you can probably figure out. I also have a personal blog that you can read. It has a lot of technical details. So we saw from different presenters today how a typical big data environment looks like. You have the ingestion part, whether it's from the internet, from Internet of Things, whether it's log files, ETL. And then we have different types of processing. We have the sort of memory-based, Spark, Storm. We have the batch-oriented, MapReduce. We have different other tools. And what you see is that you have many different tools in this environment. And every 2 days, you have a new tool that you learn about. In this convention, I learned about 2 new tools. Spark is just new. I already heard from customers, no, it's old, and there's a new thing. So those things keep on changing. And there are some challenges with those. So one of the big challenges that each one has sort of ties to the physical infrastructure, has a very different footprint in terms of infrastructure. Let's assume you just bought your MapReduce brand new cluster and you want to run Spark, which is much more memory intensive, and now you need to replace your machines, take some disks out and add some memory DIMMs. And maybe someone is building MongoDB or Aerospike, and they're very keen about SSD, and they don't like hard disks. So every application in this space have its own sort of footprint in terms of hardware. Much of the challenge is more around the persistent layers, the memory, the storage, hard disk, SSDs, etc. What you see is when you build those solutions, you have to maintain at least 3 copies for the Paxos consensus algorithms, for the replication, etc. So it's very difficult to build those. And since each one of them ties to a physical infrastructure, it makes this even more complicated. It's not only 3 copies, because each one has its own repository of data. So what you tend to do is have the same database stored in multiple places, because you have to basically run it in Oracle and then move it from Oracle to your Hadoop, and then from maybe another staging environment, etc. So this is what we see, and we see companies like LivePerson, Outbrain, and others in Israel. They build a solution, but it takes them 3 years. And when you go to the enterprise customers, they want something which doesn't require a very strong DevOps orientation, and they need something which is more plug and play. So what would be the obvious solution? And let's go virtualization. We talk to people, say, why don't you virtualize your big data infrastructure? And they're saying, well, are you crazy? It doesn't work. And this is sort of the typical answer that we get. If you look at implementations in Amazon, you typically, when you do big data, you use local disk drives. You don't use EBS, you don't use elastic storage. And why is that? Because if you're trying to put something like Cassandra or HDFS on top of a virtualized data management layer, it have its own sort of RAID functionality and replication and all that, it adds a lot of latency. It adds a lot of unpredictability. So if Hadoop has some assumption around locality of the data, then when Amazon or someone else is building an infrastructure that puts things scattered across different machines, then you won't get the same consistency and the same performance, same latency, etc. There are other issues. If you run, for example, HBase, it really likes to sit on the data. And now if you're trying to move Docker containers, which doesn't have any virtualization of a disk, into a different machine, and the data stays in the other machine, you're challenged by those things. So what do people do? If we take the Amazon case, they would take something like S3 and object storage. What's good about object storage, if you're not familiar with that, it's infinitely scalable. You don't put quotas on S3. Amazon wants you to basically use as much as you want and just start paying more and more. It's globally distributed. Many of the guys building big data have the challenge of how do I distribute across different disaster recovery sites. And it has a very good durability because of all the erasure coding technologies. And now the nice thing is I can ingest data from Internet of Things to this repository. I can run different applications directly on this data. And then when I have some results, I can have someone present those into my tablet. But it comes with few challenges, which doesn't make it optimal for this big data. And by the way, it's not just Amazon. If you look at Facebook and how they build their Haystack, if you look at the Azure and Blabster and all those technology, basically all the tier one vendors, this is how they structure their systems. Basically have very big repositories where all the applications talk to, and this is becoming very efficient. But again, there are a few challenges and what's missing in those layers. So the first thing is performance. If I'm using this as my repository over the internet, performance is not important. But if I'm trying to run an analytics job on top of the same data, then latency really counts. If my round-trip latency to the data is high, that means I use a lot less transactions. I can do a lot less transactions for the same CPU. Same for bandwidth and other aspects. I may want to read a petabyte or a few terabytes, so performance is really critical. Consistency is another big problem of those solutions. If you go to Amazon S3 and you look a bit about examples of consistency, they're saying if you write in this order, what you read can be this, can be that. You have all sorts of answers for that. And that's not good when you have data tasks. When someone is generating a transaction and another one needs to read it, you have to provide consistency. And there are other aspects like application integration, security. We heard a lot today. So what did Amazon do? They said, okay, so we need an extra layer, and it's not just Amazon, also the other cloud provider did the same. They basically built another layer on top of the object storage to deal with those challenges. So this is an example for Amazon Aurora, which is their SQL, scale-out SQL database. And basically they move some of those caching layers and consistency and logging to the database. And this way they manage to provide something which is based on MySQL and is way more scalable and higher performance. Okay, so the general idea, if you look at Amazon, Kinesis, and Aurora, and DynamoDB, and the other solutions from the other cloud vendors, is basically moving from object storage as sort of an archiving use case to add more elements to it to become sort of the primary solution. So my presentation is short. So again, we're not really talking about what we're doing, but we're trying to address those 3 V's and simplify the infrastructure, make it much more enterprise friendly. We're hiring. So yes, any questions? Okay.